Greetings everyone. My name is Daksh Malik. I am BTech first year student at IIT Roorkee of Geophysical Technology branch. Our course coordinator of Tinkering and Mentoring 103 is Professor Rajat Agarwal sir. Under the guidance of Gunjan ma'am, I have prepared this presentation on marine geophysics and subsea resource mapping. Firstly, let us talk about the introduction. Marine geophysics basically focus on studying the physical properties of the seafloor and subsea floor using geophysical techniques, for example, using seismic, magnetic or gravity surveys. Now, talking about the introduction of this project, it will help us in understanding the seafloor structure that will further help in resource management, natural hazard assessment, for example, the assessment of earthquakes, tsunamis, and environmental conservation. Top 5 patents in this field are: first is from China, and the title is Shipborne Submarine Marine Geophysical Data Processing and Analyzing System. For example, imagine you are trying to map the ocean floor using a ship on the surface and a submarine deep underwater. Normally, you will collect all the data and save on hard drives, and it will require a lot much of time, for example lot many weeks, for that data to process and actually understand what was there in that data. This patent is for a system that changes that. It actually acts like a powerful high-speed translator that takes raw signals like vibrations or magnetic readings and turn them into a clear map instantly while the ship is still moving. It is designed to filter out the noise caused by the ship's engines or the waves, allowing scientists to see mineral deposits or underwater structures in real time. Next patent is also from China, and the title is Marine Environment Data Processing Method and Device, Electronic Equipment and Readable Storage Medium. So actually, what is the problem? The problem is that ocean data is messy and comes from many different places at once. For example, sensors, buoys, ships, and making it hard to process quickly. So what is the solution that this patent suggests to us? It tells that we can use a specific digital tool that acts like an automatic filter and sorter. Next patent from China is method for measuring and locating marine station structure suitable for slit coastline. This is a high-tech measuring tape for building structures like research stations or docks on soft muddy coastline. Slit coastline is a very important feature of marine geophysics, and basically this patent revolves around that topic. This patent suggests us the solution that we can describe the method to mathematically pinpoint the perfect location and depth for these structures. It uses specialized measurements to account for how the soft mud moves and shifts. So basically the result is that it ensures that marine stations stay perfectly level and stable even when they are built on ground that act more like a liquid rather than a solid. Next patent is from USA, and basically it is related to system and method for gathering marine geophysical data. It suggested a system for creating a 3D ultrasound of the earth beneath the ocean floor. Actually, the problem that we face in the marine geophysics area is to find oil, gas, minerals. Scientists need to see deep under the seabed, but traditional sensors are often difficult to position correctly or get tangled in fishing nets. So basically the result is that it provides a highly detailed 3D image of what lies beneath the ocean floor, helping explorers find resources with much higher accuracy. Next is from China, Coastal Zone Land Space Purpose Monitoring and Investigation Method based on Water Resource Dependence Degree. The concept is very simple, that this is a smart monitoring system used to decide how coastal land should be used based on its thirst of water. What is the solution? The solution is that this method investigates land by looking at its water resource dependence degree. Basically, it measures how much water different activities or plants need to survive in that specific plot. The result of this is that it helps government make smarter rules about where to build and where to protect nature, ensuring the coast doesn't run dry or become overlapped. Next, there are certain relevant standards in this field. Key BIS standards. First is standardized data content, All geological and geophysical data must use common terminology and consistent formats so datasets can be combined and shared across projects. Next is accurate geospatial referencing. For example, if we look at countries like India, where there is a huge landmass, so there is difference of nearly 2 hours between Arunachal Pradesh and Gujarat. So data must be standardized according to Indian Standard Time. Next is quality control. Strict rules govern survey, equipment performance and accuracy. It is very important that the resources and the materials that we are using must be in a workable condition. Next is standardized reporting. Final survey results and technical reports must follow a predefined template. For example, if we take the case of MERT, ensuring consistency and easy review by regulations and researchers. Key ISO standards in this field, first is related to metadata and next is related to spatial schema. Labels describing dataset content, collection data and accuracy. Next, relating to spatial schema is that standardized geometry, points, lines, polygons for mapping features. State of technology in this field. The current technological landscape is mature and diverse, driven by sophisticated hardware, advanced software, and comprehensive modeling. Looking at certain areas, first is mapping and remote sensing. LIDAR, multispectral imaging, and seafloor mapping systems, fully commercialized for high precision bathymetry. Next is data tools, widely adopted softwares, for example, CMG tool, CO2 calc for visualization and carbonate system analysis. Next is laboratory and instruments. That all the commercial GPR and core logging systems, specialized labs for sediment and carbon studies must be taken care of. Next is modeling and forecasting. Research driven but applied systems, for example, Cosmos or QuAFST for hazard prediction, coastal planning, and digital twin development. Talking about ethical considerations relating to this project are, first is that environmental protection. It is very important that we look at the environment because sometimes deep sea exploration harm fragile ecosystem and lead to the disturbance in oceans. Next is sustainability of resource use. Resource extraction must balance economic gains with long-term ocean health. We should not compromise the long-term ocean health with just taking care of present. Next is data ownership and sovereignty. Seabed data cross borders. UNCLOS, that is United Nations Convention on the Law of the Sea, provides a framework but disputes always remain there. Equity and fair access. Developing nations risk exploitation due to limited technology access. Transparency and accountability. Government and companies must disclose impact and share findings responsibly. Now I will tell you a leading startup in this field. The startup is Plenus Technology Private Limited, that is related to deep tech robotic startups. Headquarters and reach. Global headquarters of this startup is in Chennai, India at IIT Madras Research Park with an international office in Rotterdam, Netherlands for European market access. Core market serves major Indian clients in oil and gas, ports, power, and civil infrastructure with active expansion into Europe and Middle East. The mission of this startup is that it aims to be a global leader in customized automated inspection by replacing time-based maintenance with data-driven risk-based protocols using marine robotics. The major work that this startup has done is basically that it is a rare Indian OEM, that is original equipment manufacturer, designing and manufacturing its own fleet of ROVs, for example Beluga, for AI-enabled subsea inspection and mapping. The key challenges that this is facing is related to the large scale funding that is needed for research and development in this field. Next, it also faces a challenge in recruiting and retaining highly specialized deep tech talent. Future trajectory, that it focused on product diversification by accelerating the deployment of AUVs, autonomous underwater vehicles, and achieving global scaling in international markets. The business idea of me is that autonomous subsea survey and data analytics service. Problem and opportunity. Traditional subsea mapping is inefficient and costly, relying on slow, crude vessels, while demand for highly precise seabed data for offshore renewable energy and infrastructure is rapidly growing. Solution and technology. The solution that I would suggest is that we can use low cost autonomous underwater vehicles for data collection, complemented by proprietary AI software that provides clients with instant actionable insights and hazard detection. Market customers and revenue. The primary market in the offshore wind industry with additional target customers being owners of model, project based fees, and data platform subscription fees. Next, the future vision that we can think of this business idea is that the vision is to create the most complete, live, digital twin of the ocean floor, transforming mapping from an occasional service into an accessible, continuous digital utility that accelerates the blue economy. Some of the references is NIOT Annual Report, Ministry of Earth Sciences, International Journal of Marine Geology and Geophysics elsewhere, UNCLOS Guidelines 1982, Derwent Patent Database, BIS and ISO guidelines, documents on geophysics exploration. Thank you. Have a nice day.